So, my presentation is on finding a specific term from a binomial expansion. So why is it important to understand this process? Because everyone's always like, oh, when are we really going to use math? Why are we learning this? I'll tell you. So sometimes it's straightforward to identify a specific term like binomial expansion when when n is an integer with a low value, and you can either do that by multiplying out each binomial, or you can use Pascal's triangle. But sometimes n is going to be an integer with a very high value, and it will be very difficult to do all that work. So I'm going to show you the easier way and what I think is the best way. But before we get into that, we have to consider the patterns. So what is this? Does anyone know?
It's an expansion.
Yep, it's a binomial expansion. So, as you can see, there are many patterns going on here. The number of terms is 1 more than n. So n is the exponent. And remember that, guys, because we're going to be using that a little bit later. So, the number of terms is 1 more than n. So, since this is 1, the number of terms is going to be 2. The power of a starts with n and then decreases by 1 each term. So the power of a starts with n. So see, in this example would be 2, and then decreases by 1. So it goes a to the power 2, a to the power 1, and then a to the power 0, meaning there's no a there. Power of b starts with 0 and increases by each term. Vice versa. So there's no b here, but it's b to the power of 1 there. You guys see how that works? And then the sum of the exponents in each term adds up to n. So if I add up the number of exponents in here, 4, it's going to equal 4. So 3 and 1, 4. 2 and 2, 4. Make sense? And then the coefficients of the first and last terms are both 1, and they follow Pascal's triangle. So here and here it's 1, here and here it's 1, so last terms of each. Everyone understand the patterns? All right, we can get started.
Yeah.
Now, here is a shortcut for identifying terms in a long expansion, but I'm going to call it the magic formula, because that's so much more fun to say, and it's better than repeating that. So, here is our magic formula. Take a good gander at it, because we're going to be using it. The best way to understand how to work this process is through an example. So first I'm going to explain an example to you guys, and then we're going to do one together. So, find the fifth term of 3x minus 4 to the 12th power. Look at that high integer of n. We're definitely not going to multiply out each binomial. So, first thing we want to do is we want to set up our formula. How do we do that? By defining our variables. So another way you can read this example here is find the r plus 1 term of x plus y to the nth power. That makes it a lot easier when we define our variables. So, by referring to this, what would x be? It would be 3x. Does everyone understand how it works? So x is 3x. Y would be negative 4, because since, do you have a marker? No. Because since we're referring to this, it would be 3x plus negative 4. Does everyone understand that? Okay, so y would be negative 4. R plus 1 would be 5, because we find the fifth term. And then to find r, we would subtract 1 from r plus 1, we get 4. And then n, like I said in the beginning, is our exponent. After we get our variables, we plug them right into our magic formula. Everyone still with me?
Yeah.
Amazing. Next thing we're going to do is solve our 12C4, which is a combination formula if you guys recognize it. And here's our combination formula right here. And it is n factorial over r factorial n minus r factorial. This is commonly used in probability. I'm sure you've all seen it before. And we're going to use this because when we were setting up our magic formula, you guys saw that we had 12C4. So we got to solve for that coefficient, or that number. So we plug in our numbers, and after we solve the formula, we would get 495. Does anyone have any questions for how the combination formula works? Okay. Finally, as Miss Trejo says, we plug and chug. So, plugging in the numbers and solving. So after I have solved the combination formula and got my number, it's arithmetic. I just plug all those numbers in my calculator, bam. Here we are. And I believe that is 831,409,920 x to the 8th power. Okay, that's basic math there. It's all PEMDAS. You guys know how to do that. So let's do one together. Okay. I'm going to write our magic formula down because I didn't expect you guys to know it.
Lexi, if I may ask, what does the T stand for?
Term. Okay. Does anyone remember what I referred to when we were defining our variables? Define the blank term. Remember when I was...
R plus 1.
Yeah. So find the r plus 1 term of x plus y to the n. So let's help me out and let's find our variables. So what would be r plus 1?
3.
3, meaning that r would be,
2.
here we go. What would x be?
2x.
2x, exactly. And what would y be? And last but not least, what would n be?
6.
Wow. Good job.
Thank you.
Now what we're going to do is we're going to plug these variables into our magic formula. So let's go ahead. Okay, what's the next step, guys?
You gotta do your 6 choose 2.
Yes, we have to use our combination formula to find out the number for this. So, does anyone remember the combination formula?
I know we just plug.
You could plug it into your calculator, but since we are smart IBSL math students, we can use our brains.
You can.
So, it's going to be n factorial over r factorial n minus r factorial. So, we got over 2 factorial, and then 6 minus 2 is 4. There we go. I'm going to refer to my notes here. And that would come out to 15. There we go. Now, what's the next step, guys?
One chug.
Plug and chug. So, after we square we raise 2 to the 4th power, x to the 4th power, y to the 2nd power, and then we multiply all of that by together, we are going to end up with the beautiful number of 240 x to the 4th, y to the 2nd. Good job, guys. Does anyone have any questions before we move on to the application? Because we want to get all this basic stuff down so we can really apply ourselves. So does anyone have any questions? No? Good. I must be a really good teacher.
I think you are.
And look, there it is. All the work. Application. Like I said before, you can use this in probability. So let's say we're taking a multiple choice test. And you didn't know to study for this multiple choice test. You're like, oh dear, I'm going to have to guess on everything. So you're like, but what is the probability that I get 7 out of 10 right? Because I need exactly 7 points to keep my grade in an A. So you're like, what am I going to do? Well, now you know what to do. Because I'm going to tell you. So you're taking a 10-question multiple choice test. Each question has 4 choices, and you guess on each question what's the probability of getting exactly 7 questions correct. First thing we're going to do, like in our regular math equations, we're going to define our variables. n would equal 10, because in this case we are taking a 10 question multiple choice test. R would equal 7, because we want to get exactly 7 questions correct. And x represents the chance of choosing the correct answer. So since we have 4 answer choices, the chance that you would get one correct is 25%, also 0.25. Well, y would be getting one incorrect, which would be 0.75 or 75% of the time you would completely guess. Yes.
Why is R7?
R7, because n is the total number of questions, while r is going to be the number that we're looking for.
Didn't we say that it was R+1?
That was because we were looking more at finding a specific term. This is different.
Okay.
This is using this kind of, it's the same process but using it in probability.
Okay. So you're
Okay.
just
You're
like,
going
you
to
just
see.
take it straight from my question.
Yes.
Okay.
Here's our application formula for this specific problem and when we do probability like this. Now, there are 2 things different about the magic formula and the application formula. Same process, but there's 2 things different. The first thing is, you don't see t r plus 1 because we're not looking for a specific term, but instead we're looking for the probability. So when you set up, it would be the probability of 7 out of 10. The second thing that's different is that our what we raised the x and the y to has switched. So in the magic formula, x was raised to the n minus r and y was raised to the r, but it has switched. So those are the 2 things that are different, but the same process. So what we would do is after defining our variables and understanding our application formula, we would first use our combination formula to find that number, then we
Plug and chug.
plug and chug. There we go. And since there are no x or y, since x and y is a number instead of being just like a letter or something representative like a variable, you would just have numbers, so you'd come out to a specific number. This is going to end my presentation, but I'd just like to say one thing about the application, how you can take it further. They can also ask you, hint on my assessment, to find the probability of getting at least 7 correct if 7 are the probability of passing if 7 is the passing rate. Now what you'd have to do is you'd have to find the probability of 7 out of 10 correct, find the probability of getting 8 out of 10 correct, find the probability of getting 9 out of 10, 10 out of 10, and then add all those numbers up, because that's the probability of passing if 7 out of 10 is the passing score. You guys understand that? Yes, sir.
So you'd have to do all of them manually?
Yes, because this is finding the probability of only getting exactly 7. So if the probability of passing, if 7 is the passing score, you could also get 8 out of 10 correct, 9 out of 10.
So you have to do probability of 8 and probability of 9.
You'd have to use this process for 8 correct out of 10, 9 correct out of 10, and 10 correct out of 10, and add each of these numbers up. Okay? Anyone have any questions? Everyone learned something? I can see it all on your faces. Thank you,
I
guys.
think practicing in front of your cats is really what made this presentation.
It honestly helps so much. They provide the best feedback.